So in this video I was talking about arc sine and arc cosine, in other words the inverse functions, trig functions, and so I'll do a couple of these at the top here, but then also I want to look at solving some trig equations. And so just start out here, arc sine of 1. This means that I want to know when sine is equal to 1, so it might be helpful to draw a little unit circle here, or just think of the sine curve. Either way, you should come up with, on the unit circle you're right there, sine is equal to 1. If you're thinking about the sine curve, sine is equal to 1 right there. So either way you come up with pi over 2. Okay, and since I'm looking for arc sine, I'm not looking for all the answers, just the one functional answer. So same with arc cosine of 1/2. So in this case it's probably easy to think about the unit circle. Cosine of 1/2 would be at that angle, which is the 60-degree reference angle. Or in radians that would be pi over 3. So this would be pi over 3. Arctan, when is arctan equal to -1? So we know that tangent is 1. I'm sorry, when is arctan of -1 is asking the question is when is tangent equal to 1? Or when is tangent equal to -1? So we know that tangent is equal to 1 there and there, or equal to -1 here and here. So now when I'm doing arctan, that means I'm looking at there's just one answer, and remember the answers, the range of possible answers of arctan are from -pi over 2 to pi over 2. So that means we're looking at this answer right here, and that would be -pi over 4. Notice that 7 pi over 4 has its terminal side there, because 7 pi over 4 and -pi over 4 are coterminal angles. But we're looking for keeping in mind that arctangent has to come from -pi over 2 to pi over 2. The answers are found in that range. So that's why we chose -pi over 4 as our answer. Okay. And when I get to arc secant, I actually automatically think of arc cosine, and I just flip this thing over. Same thing, because secant and cosine are the reciprocal of each other. So then I'm asking myself, when is cosine equal to rad 2 over 2? Well, that's the 45, or that's the pi over 4 reference angle. And since it's positive, I'm looking for the answer in the first quadrant, so that would be pi over 4. Okay, look at number 8 down here. So in this case, you are really asking to take a cosine and then undo a sine. So that's kind of a little bit strange. So you could just do this one piece at a time. So you take the inverse, leave inverse sine alone, and just take cosine of 3 pi over 4. Of course, cosine of 3 pi over 4 is negative rad 2 over 2. Okay, so then I'm going to take the sine, the inverse sine of that. So I'm asking myself, when is sine equal to negative rad 2 over 2? Well, if I'm thinking about the unit circle, oops, that was an ugly unit circle. I'm thinking about the unit circle. I know there's negative rad 2 over 2 there and there. But again, when I'm looking for answers for inverse sine, they have to come in the same interval as arctangent. So we're looking between -pi over 2 and pi over 2. So we would pick that one, and we wouldn't call it 7 pi over 4, we would call it -pi over 4. Okay. So that's enough of those. I'm going to move down and hit a couple of equations, like number 11 is a good example. So if I'm trying to solve for theta, I just have to undo everything that's not theta. So I begin on the outside. Got to get rid of that squared, so I square root both sides. So that would be 2 cosine theta is equal to the square root of 2. Then I divide both sides by 2, and I get cosine theta is equal to rad 2 over 2. And now I'm just going to use my knowledge of the unit circle, because I know the unit circle. Cosine is equal to rad 2 there and there. So that would be theta is equal to pi over 4 for sure. Now this one is in the fourth quadrant, so I could call it negative pi over 4, or I could call it 7 pi over 4. But of course, up here I said look between just 0 and 2 pi, so I want to pick 7 pi over 4. And of course I could spin around the circle more and hit this again. So in other words, if I went all the way around the circle and landed there, that would be 9 pi over 4. But I don't include that in my answer because it said look just between 0 and 2 pi. So we'll throw that one out. Okay? I want to do one of these with cosine with a 2 on the inside. So the first thing I would do here is undo the cosine. So I'm saying when is cosine equal to 1? So that means 2. So in other words, if I undo the cosine, I get 2 theta is left. So when is cosine equal to 1? Well, you could picture the graph or the unit circle, but I notice it's 1 right there, right there, right there. So that's at 0, 2 pi, 4 pi, etc. So cosine is equal to 1 at 0, 2 pi, 4 pi, 6 pi, etc., right? But notice what we've found so far is 2 theta. I'm actually looking for what theta is, so I have to divide all those by 2. So then I get theta is equal to 0 divided by 2 is 0, 2 pi divided by 2 is pi, 4 pi divided by 2 is 2 pi, and 6 pi divided by 2 is 3 pi. But notice 2 pi is outside the interval, right? I'm looking for all my answers between 0 and 2 pi. So that means I don't need that one. That's outside the interval. So my only answer would be 0 pi and 2 pi. Okay? Go over to this one. This is tricky because there's sine squared and sine. So we can there's a nice little technique called U substitution where you can say, just for a moment, this is too complicated for me, so I'm going to define U to be sine theta, and then rewrite this, so that would be 2u squared plus u is equal to 0. And you can see what that does. It turns into a nice algebra type equation that I can solve, because I got a quadratic equal to 0, so I could factor out a u, and that would leave me with 2u plus 1 equals 0, which means u has to be equal to 0, or 2u plus 1 is equal to 0. But then I remember that I substituted u in for sine. So I'm not actually looking to solve u, I'm actually looking to find what theta is. So then I come back down here and say, well, u is actually sine theta, so what I'm really trying to solve is sine of theta equal to 0, and 2 sine theta plus 1 equal to 0. So I'd have two equations here that I need to solve. So when is sine equal to 0? That would be at pi over 2 and 3 pi over 2. And this, of course, would be when is sine of theta equal to negative 1/2, because I subtract 1 divided by 2. And that would be in the fourth quadrant and the third quadrant. So theta is going to be equal to 7 pi over 6, just a little bit past pi, and 11 pi over 6, just a little bit before 2 pi. Okay. I think I'll stop the video for now.